Good morning, Mr. Johnson.
Good morning. Did you guys go to the fair last weekend? No?
Did you?
Too hot and crowded for me.
What do you like to do on the weekends?
What do I like to do?
Yes,
Sleep
sir.
and play video games. What do I get to do? Catch up on chores.
Do a lot of projects around your house?
I try not to, but that's part of owning a house, is you end up having to. So.
Yeah.
No, I do a lot of stuff over the summer, but I've still got a few things I'm trying to finish up before the weather gets cold.
No way. That's what the lady said.
Yeah.
That means that's a major thing, right?
Yeah. If you have to reach out to colleges and tell them I got ISS.
What?
You get ISS for what?
Opposite, if you don't have your ID, administrators can give you ISS.
Oh my goodness.
Seems like excessive.
Wait,
That's at
what?
least with the lady at the front door told me.
Maybe they were
Maybe
joking
she's,
with
you
you.
know, spinning the story off something.
I mean, I will tell you that not having your ID does go in as a major referral. And last year, if you had more than one, you couldn't exempt finals. But this year, the exemption rules have changed.
Do you allow exemptions, Mr. Thompson?
Not first semester.
The second semester.
Well, second semester, we won't even have a final, so. Well, probably.
We got 5 minutes.
It's the first time it's ever happened. Last year, you couldn't exempt it both.
We don't have this final second semester, right?
No, last year they did.
Really?
Yeah.
But we're seniors this year, so it doesn't matter.
For an AP Chem final?
I'm not in it if you can't. I'm not thinking that.
Yeah, see,
It's low key easy.
we haven't even gotten into
Oh, yeah, we have.
We have.
The stuff we're doing is pretty hard. It's like,
Wash my face.
I mean,
By the time I wash
pretty hard.
I guess that's hard.
Well, it's like a whole mess. How do you go on
time is it?
Dude, I remember what we did.
Morning. 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 Just you wait till 1:45. Good morning, Master Townsend. On time, too. No, I
Everybody's here today.
early. Today. I've done all the homework. I've done the packet.
Yeah, I'm sure you
You want to see my pen? You got a key, right? Can I turn in number 40?
Sure.
You didn't do it, yeah. You didn't do the last half. That's all right.
What?
You're not silly.
Well, yeah, I haven't done 1.5.
Oh.
All the way up to 1.5. You haven't even done 1.3.
I didn't even know 1.3.
And then were we supposed to do B on this? Or just leave it?
Just leave it. We're
Okay.
actually going to go over it today. I would think I went over it with them, but I did it wrong. So,
Nice.
anyway,
Cool. Thank
we'll
you.
learn from my mistakes.
We were out there.
Let's go posters. What'd you get?
Brady.
And the chance to enter bad. It's like 3 days. It'll do the drink.
That's the best type of water. You get all the flavor from
It tastes good, but
Sorry, Mr. Johnson.
Uh-huh.
Are we supposed to turn in number 4? It doesn't say on the board, but somebody just asked.
Oh, then no, not yet.
Okay.
Maybe next time.
what did we turn in last class?
I don't know. On number 4.
Oh, number 3? I'll come get it. Huh? No, we're not supposed to have
Maddox.
time in the house. So we're supposed to turn in 3?
I don't know. Do you want to wait 2 seconds?
Okay.
Let me finish getting the things for them. Layla, Maddox, Zoe, Calvin.
What was that?
I'm not sure what to do the last two.
It was just hard. I don't know. I wasn't here. Huh? Goodness, yeah. I just
Yeah, we turned in number 3.
That was last time, is that right, Mr. Johnson?
Correct.
Okay, so 4 is this time. Are we turning in number 5 as well?
Anything I ask you to turn in is also on the board.
So that's a yes.
But when we get to it, I might want you to do something with it first.
Just trying to be proactive. So I'm planning that. That was just assignment number 3 over there from.
Cooper,
That's fine. Oh.
Okay, so we don't start moving into that.
Be announced. No, that's actually good.
Okay, under bill work, I asked you to get out assignment number 5. I also need you to get out assignment number 4 also. Please get out 4 and 5.
Thank you very much. Will you please stand as you are able for the pledge?
United States of America, to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Okay, today we need to clean up a couple things from assignments 4 and 5. Assignment 4, I had told you something wrong on the other day, so I want you to have that fixed on your paper. And hopefully that'll be a good learning experience, that you don't make the same mistake that I did. Then I'd ask you guys to try all of the stuff from assignment 5. And there's one question I need to talk to you about on there, plus whatever other ones you thought tended to be a little bit harder. Then I'll go ahead and collect that one. Then we're going to talk or introduce the second BC topic, something called integration by parts. So that's one of the handouts y'all picked up. But we're only going to do some of that today. So I'm just introducing you to it today and having you practice a couple of them. We'll worry about finishing that up later on. And then the other handout you should have picked up is what we did last time, partial fractions, but this one just has you do a little bit more practice. So those questions should be the same as questions from assignment 5, but I'm just giving you more time, more practice to make sure you have that skill under your belt. So assignment number 4, the thing I need you to fix on it, and I think I had mentioned this verbally, but I don't think we looked back at it as a class. What number was it? Oh, 4A. Is that what that up there says?
No, it says fix number 4, 2B.
Okay, let me look. I don't remember what the question was. Was it this one? 4 2B. Oh, okay, you're right. Okay, look at this one, please. So I'm on assignment 4, question 2B. I think I worked this one out for you guys last time, but I had one mistake at the beginning, which made me think it was those partial fractions that we practiced last class. And the mistake that I had made was when I tried to factor this, because you know we try to rewrite it like this with smaller fractions that are easy to integrate. I think I had said something like this factored as an x plus 4 and an x plus 1 or something. Is that what your paper says? But notice that's not how that factors. 4 times 1 is not 5. So because I misfactored this, I thought it was this type of integration, but it really should have been another completing the square question. So I apologize, but what I hope that you learn from that is if you factor it too quickly and incorrectly, you might also do like I did and miss it for that reason. So let's go ahead and talk about completing the square again. Because I know this is not something y'all have practiced much. And if I can find a worksheet on the internet that has some good practice problems of these, then we'll definitely take some time out this year to do that. But basically, to complete the square, you're just trying to add a separate number, or a certain number here, that makes this factor as a perfect square. Something times itself. Now, you could guess and check. If I put a 1 here and factored it, I don't get the same thing times itself. I could try putting a 2 here, and if I tried to factor it, I wouldn't get the same thing times itself. There's a little bit of a shortcut. Does anyone remember the formula I told you, how to find that special number?
Something about B.
B over 2
squared.
B over...
Squared over 2.
B over 2 squared.
B over
All
2 squared.
Yeah.
Oh, that's it.
Timmy wasn't even here last class, and he knows.
Yeah, I watched the recording.
So, good.
There we go.
So if B is 4, half of that would be 2. Square that, you get 4. So the magic number you want to add is plus 4. That's why I'm doing this in a different color. But you can't just add 4 to the denominator and expect it to be the same question. So you also need to subtract 4. Whatever you add, you subtract. The idea is now this is a perfect square. It's x plus 2 times x plus 2. These combine to be plus 1. And I know this is still not the most familiar to you, but we do need to, if we don't practice these things as they come up, then they never get any easier. So when we rememorize the derivative of inverse tangent, there's really only 2 inverse trig functions you need to know real well, at least from AB. It's inverse sine and inverse tangent. So if you know this, you recognize, wait, this looks a lot like this, but instead of plugging in an x, they're plugging in an x plus 2. So your answer would be inverse tangent of x plus 2 and then a plus c. So again, one, I just wanted you to have it correct on your paper in case you look back at this as a resource in the future. But two, again, try to learn from my mistake. I thought that denominator factored, so I thought it was partial fractions. I misfactored it, and then I spent a lot of time, and I had no indication that my answer was wrong. Okay, does everybody have this one updated on your worksheet? Okay. Then the next thing I'd like to briefly talk about on assignment 5, there's one thing I need you to add to the very top of your notes. It's actually typed up here, but I didn't read it either, so I can't expect that you had read it. So to do these partial fractions, that's where you take a big, this is what we did last time, you take one big fraction and you figure out algebraically how to write it as two small fractions. And once we figure out how to rewrite it as two small fractions, the integration is a lot easier to do in our head. But there's one big key in here. This only works if the degree of the numerator is smaller than the degree of the denominator. You can only do partial fractions if the degree of the denominator is bigger. So with that in mind, one of these questions last time, you had to start off with long division, and I didn't know why. And again, it was because I skimmed through this too quickly. So let's go to, we're going to do two things with this question. Question number 6. So if you didn't start this question with long division, again, I don't blame you. That's more my fault this time. But we're going to go ahead and do this one together so we can talk about the long division so that we can correct it if you tried it on your worksheet, but also as a reminder from last week, because I'm going to have you practice some more partial fractions the second half of class. So first off, make sure that in your notes you write down that you need to do long division. The degree of the numerator is not smaller than the degree of the denominator. Okay, and if you need some help or brush up on long division, just let me know today. But basically, the thing times x squared that gives you x cubed would be x. Subtract all of this. Oops. So negative 11x plus 8x would be minus 3x, and negative 15 plus nothing is negative 15. Okay, go again. Looks like the next part of our quotient should be 2. 2 times x squared is what gives you 2x squared. Make sure you subtract all of these. Now, even if you remember how to do long division, you need to remember how to piece your answer together. This divided by this is the same thing as the quotient, the thing on top, plus the remainder over the divisor. And unlike grade school, you can't just say r x plus 1. That doesn't mean anything. You did the r thing in grade school because you didn't know about fractions at that point. You've got to take the remainder over the divisor. So this was the only question you had to do this one on. This was the only one where the degree of the denominator was not bigger than the degree of the numerator. Now, to finish this question, we still got some more work to do. We're still going to have to do partial fractions on this question. But notice, if you don't do this, you're never going, I'm going to integrate part of this right now. This integrates as a 1/2 x squared. This integrates as a 2x. And you're not going to have either one of those values if you don't do the long division first. Now, to do this part, this is going to be a partial fraction now. None of our other integration techniques look like this. Integrating a big fraction is kind of your key here, and that the denominator factors. So I'm going to, so that I don't lose all of this, I'm going to try to like box in where my answer needs to be. I need to remember these two become part of my answer. So again, this is a reminder of what we did last week because I'm asking you to practice more of these today. We're going to take this big fraction that we're trying to integrate, and we are going to make it into smaller fractions with the same factor denominators. And these smaller fractions are a lot easier to integrate. That's the purpose of doing that. So first thing you need to do, hey Trayvon, what you need? What's up, bud? It's second period right now. Do you have your schedule with you? Yeah. Or I'm sorry, it's first period. First period. You need me to look up where you're supposed to be? Okay. Okay, so I'm going to get rid of all of these fractions by multiplying everything by x plus 2 and multiply everything by x minus 4. So we get x plus 1 equals a times x plus 2 times, or plus b times x minus 4. Now, keep in mind, a and b are supposed to be constants, so they should always be the same number no matter what x is. So if you want to plug in 100 for x, you can. It just doesn't help you solve for a or b. If you want to plug in -2 for x, it's going to help a lot because it's going to make the a's go away. So plugging in -2 for x, this goes to 0. And it looks like b is 1/6. And then to make b go away, I want this to go to 0, so I'm going to plug in 4 for x. And that's going to leave me 5 equals 6a. So a is 5/6. And then now we can integrate these small fractions. Integrating a over x minus 4 would be a times the natural log absolute value of x minus 4. Put that up here with my final answer. Plus b over x plus 2. So integrating b over x plus 2 would be 1/6 natural log absolute value of x plus 2. And then of course the plus c. Now the interesting thing about this one, or interesting in my opinion, is that you actually end up with, you get all of this stuff if you don't do the long division, but if you don't do the long division, you're never going to get those first two terms. You need all of that. Okay, so now we're going to kind of split class into two different paths here. I'm still, before I take this one up, again, I asked you to have tried all of these on this worksheet. So if there was any of them that you found to be harder, I want to go ahead and clear that up for you. So I'll take a question or 2 or 3. But for those of you that don't have questions and you feel like you've got a pretty good grasp on partial fractions, or if somebody asks a question that doesn't apply to you, use that time, try on this worksheet 7 where I'm going to ask you to practice these partial fractions again. You don't need to ask, then that can be your productive time there. Okay, so for those of you that had trouble with some of these, which ones did you find to be harder that you'd like to talk about?
Number 7.
Me too.
Number 7?
Me too.
Timmy, was that your question?
Yeah.
Okay. Okay, so first off, one of the things is a lot of people thought this was 0 to 50, like it was saying this. It's not asking you to find the total from 0 to 50. It's just saying that this only exists from 0 to 50. So antiderivative, they were really wanting you to work this. This is the question they're asking you to try to solve. What is the antiderivative of that? Now, this is a partial fraction because the denominator factors, and we're trying to integrate a big fraction. I know that doesn't seem important now, but when I show you a couple other methods, you've got to identify this is this question type and not that question type. So I'm going to rewrite this. 1 over p times 50 minus p is the same thing as something over p plus something over 50 minus p. Get rid of the fractions by multiplying everything by p and 50 minus p. Plug in temporary values for p, like 0, so that you can figure out a is 1/50th. What would be the other number I would want to plug in for p?
50.
All right, good. Plug in 50, makes this go to 0, and you'd be left with 1 equals 50p, 50b. So b is also 1/50th. So I'm just going to go back up here and change this so you can see this connection with what I was talking about earlier. Now that I know a is 1/50th and b is 1/50th, and the whole point of this question was to integrate this stuff, I'm just showing I can integrate these two smaller things and get away with the same thing. So constants can be pulled out front, so this would be 1/50th natural log absolute value of p. How does this integrate?
Is that 15?
It is a 15. No, it should be a 1/50th. So the constant can come down out front. That makes you feel better. So it's going to be 1/50th times. How does this integrate?
Natural log of 50 minus p. Absolute value.
That's close. And that's what most of you put down, I think. If I take the derivative of this, the derivative of natural log of something gives me 1 over the something, right? But do you see how there would be chain rule here? This is multiplying by a -1. So you need to multiply this by a -1. If you don't see why you need to multiply by -1, you really need to slow down and do u substitution on this. Plus c. Okay, so several of you had that question. Was there something more specific about 7? That's enough? Okay. Somebody who did not ask for this one, have another one that you thought was harder than the others?
Can you do number 8?
Number 8. Okay, so number 8 is certainly going to be a partial fraction. I'm trying to integrate a fraction where the denominator factors. So I'm going to try to rephrase this as something over x plus 5 plus integrate something over x plus 1. If I can solve for a and b there, then I can do this and this pretty easy, pretty much in my head. So the first thing I want to do is I want to set this fraction that they gave to me, I want to set it up like this. This is the equation that if I can solve, then I'll have a and b that'll make the calculus easier back at the start. So get rid of all your fractions, multiply everything by x plus 1 and x plus 5. Plug in a temporary number for x like -1. That's going to let you figure out b as a fourth. Plug in another temporary number for x, like -5. That makes all of this go to 0. So a is -1/4. And then once you know a is -1/4 and b is +1/4, now the calculus should be significantly easier here. This is going to integrate as -1/4 natural log absolute value of x plus 5. This is going to integrate as 1/4 natural log absolute value of x plus 1. And all of this is supposed to be evaluated from 0 to 1. Okay, so if I plug 1 into this mess, I get that. If I plug 0 into this mess, I get that. Now, one part of this should go away. Which one of these 4 terms should go to 0? All right, natural log of 1 is 0. So, of course, adding 0 is not going to really do anything. So this is where I ended up with an answer of -1/4 natural log of 6 plus 1/4 natural log of 5. And then make sure you distribute here, plus 1/4 natural log of, oh, this is not a 5. This should be a what? Oh, this should be a 2, right? If I'd plugged 1 in here, this should be a 2. Plug 1, 6, 2, plug 1, or 0, that would be 0, 1. Okay. Sorry, that should be a 2. And that is fine with me. But they did get this to condense quite a bit. For those of you that are interested, you could pull out a 1/4, since they all have that going for them. And then with logarithm properties, you could condense a lot of this stuff. You could do 2 times 5 divided by 6, and the 1/4 out front, or 1/4 natural log of 5/3. If you want to condense it, it needs to look like that. But again, this is fine, especially for free response. Free response, you don't have to do any arithmetic for your final answer, just like you didn't have to in AB.
Could you pull the 1/4 out as an exponent?
Could you pull it up as an exponent?
Yeah.
Sure. If you'd rather do natural log of 5/3 to the 1/4, you could. Or since it's an exponent of a 4th, you could even rewrite it as a 4th root if you wanted to. That's why I don't usually spend all the time talking about all the different ways to simplify, just because you can do a ton if you need to or want to. My guess is on a test, it's either going to look like this or like this for multiple choice. Okay, anybody else had this question, have something specific about it before I swipe it away? This was number 8. Any of it you want me to address something about, talk about something again, zoom back in, any of that? Okay. Anybody who has not asked the question yet today, have one of the others. So obviously not question 6, 7, or 8, because we did those on the board. Okay, nice. Question 10. Okay, so we know this one is partial fractions because the worksheet that it's on. But again, the idea here is I'm trying to rewrite this as some number over x minus 1 plus some number over x plus 2. Because if I can figure out a and b and write it like this, I can do the integration pretty easily. This I can't do in my head. Let's evaluate from 2 to 3. Okay, so again, I don't know. I really like algebra, especially algebra that's not just the random skill that you don't get to use very much. But set their big fraction into 2 smaller partial fractions, and then solve for a and b. Multiply everything by x minus 1, multiply everything by x plus 2. That step gets rid of all the fractions. Solve for a by plugging in 1 for x, because it makes the b's go away. Solve for b by plugging in -2 for x, because it makes the a's go away. And then once you know a and b, you can go back up here and say this is a positive 1, this is a -1. Now I can integrate this to natural log absolute value of x minus 1. I can integrate this to minus natural log of absolute value of x plus 2. And all of this needs to be evaluated from 2 to 3. So that's the new part here. So are you okay with those steps? You saw what you may have missed. Okay, then evaluate. So plug in 3. Now last question, I didn't plug this in very carefully and I almost missed it. So plug in 3. This would be natural log of 2 minus natural log of 5. Plug in 2, you get natural log of 1 minus natural log of 4. Okay, and we saw this on the last question too. Doesn't some of this go away? Natural log of 1 is just 0. You need to know that one, and you need to know the natural log of e is 1. They're going to show up too often. Bless you. So distribute this. So that is fine. Or you could condense all of this. Division condenses into division. Addition condenses into multiplication. You guys remember the condensing rules there? That's a good one to review it on. Subtraction between 2 of the same type of logarithms can be division. Addition between 2 of the same type of logs ends up being multiplication. 2 times 4 is 8. Okay, so I do want to take this up and give you some points for this one. 2, 3, 4. So if you would, make sure your name is on that. And then I do need both pages. Is yours stapled? Yeah, I stapled it for you. So if you want to just pass those towards this side of the room, I'll come and collect them up at once. Got your name on that? Okay, any others?
Yes.
Okay, remember, if you forgot to finish this, you should still give me what you have and take half credit, because half credit now that you can go and finish it to get half of your points back. This number 5 doesn't have a name on it. Neither does this number 5. Neither does this number 5.
Does mine have a name? Mine is highlighter on the front.
I don't see any of them that say Kenny.
It says Thompson.
There's none that says Thompson.
Oh, okay. I'll fix it.
Is the one that says Braden?
Not that I see.
I guess you'll just have to use all of them.
I'm not giving you all hundreds. If I give you all hundreds, then you start trying less. Okay, we need to reset here. So, again, I will ask you to practice some more of that at the end of class today / for homework. So notice number 7, the linear fractions practice. Again, I will give you back your notes today so you can have those as examples, but I want you to practice a little bit more of those and finish those up for homework. But before that, I want us to, even if slowly, I want us to keep moving forward on some new stuff. So number 6, we're going to start today, integration by parts. So that's one you should have picked up on your way in. So if you were working on number 7 because you didn't have questions, that's great, but you need to rejoin us here. Okay, so integration by parts is a different way to do integration. So it's not the same question types as linear or partial fractions, because we don't need another technique to do that. We've already got a technique for that. But this one often looks like you're doing multiplication. So if we just kind of scan through here, you're integrating something times something. Integrating something times something. Something times something. Something times something. So that gives you your kind of hint. When it's integration by parts, it almost looks like you're trying to do product rule, but you're integrating, not doing the derivative. Now, there's 2 ways to know this formula. I tend to stick with U's and V's, but we'll write down both in your notes, and then you can do whichever one you want to. But if you're integrating something times something, integrating U times V, the answer to this comes from U times V minus integrating V well, let's not say that. Let's say U prime. So to integrate UV, the answer will be U times V minus what you get from integrating V U prime. I want to say du there, but now if you prefer to keep up with f of x's and g of x's, this is okay too. This is the way the notes have it, so I'm going to let you run with that if you want to. But I always learned it with u's and v's, and I think that's how most people do it.
Are U and V interchangeable, or do they have to be in the same order? As in,
You're going to pick what u is, and you're going to pick what v is.
Okay.
So it's kind of like u substitution in that way, but there's a good choice for u and a good choice for v. So it's not just totally anything. Yes?
In this case, would the like f of x, g of x be f of x, g prime of x, and talking about f of x, g prime of x and the antiderivative?
Okay, so let me show you where that comes from if you're interested. So here's the f and g stuff. So this is the product rule. When you're trying to take the derivative of something times something, you take the derivative of one of them, not the other, plus then backwards. The derivative of the second one times the first one left alone. So notice what we are trying to solve for. Look at this. Oops. This is like trying to integrate this, what they're calling f and g prime. Again, I prefer u's and v's, but just to show you that this is really an extension of the product rule. So what we could do is we could subtract this over, subtract like we're trying to solve an equation. Then we could integrate both sides. Of course, in integration you can do one step at a time. Now right here, this is saying what's the antiderivative of the derivative of f of g. So what can I take the derivative of to get the derivative of fg? One more time. just FG. So this is like your U times your V. That's where that comes from. Minus, we're going to integrate F. Notice how this is the same as the thing I showed you, times G, what they're calling G. So that's a proof of where integration by parts comes from. You just take the regular old product rule, move part of it to the other side of the equation, integrate both sides, and that's where that comes from. Okay, so we're going to do 2 examples to start off here. The first one we're going to do without a table, and one we'll do with the table. So a lot of students are going to like the table one, but the table one doesn't always work. I can't remember a counterexample at this time, but we need to practice both. Okay, so here's their tip for picking U and V. So again, I'm just going to call this U instead of saying again, if after a little bit you prefer to use F and G, that's great, but I'm going to go with this. Actually, I guess this is actually U prime. Okay, so for U, it's saying pick something that becomes simpler when you differentiate. Again, this is kind of like U substitution, but we've got U's and V's, not just U's and U's. So for G prime, or V, whatever you call it, choose something that can be easily integrated. So look at this one we're trying to do in question 1. Which one of these 2 things becomes simpler when you differentiate?
X.
Okay, so X is going to be U, and then for V, it's going to be everything else. So that would be sin X dx. U should be something easy to differentiate. V should be something that's easy to integrate. But I just put everything else down for V prime.
So is this type of problem solvable with the product rule? Or is this just is this the easier way of doing it? Or is this
Product rule is when you're trying to do derivatives. This is integration.
Okay.
It's derived from the product rule. Okay, so if I take the derivative of U, what's the derivative of X?
1.
Okay, 1 dx. Okay, over here, notice I want to integrate. I picked out V prime. I want to go backwards to V. So if I integrate V prime, I get V. If I integrate sine, what can I take the derivative of to get sine?
Negative cosine.
Very good. Negative cosine. You're going to see, especially in this type, there's lots of sines and cosine stuff. Be very careful. Check your integration by taking the derivative. The derivative of negative cosine would be positive sine, so that's okay. So then we are just about ready for our answer. These are going to integrate like this. So part of our answer is U times V, X times negative cosine X. That's this part. Minus, I want to integrate V U prime, or G prime, I'm sorry, V U prime. So I'll do that out to the side. Here is V U prime is dx. So again, I'm just plugging these things into this formula. This is the formula that tells you how to piece your answers together. Now, before I throw this over on my answer, I need to integrate this. So what can I take the derivative of to get cosine? Very good. Sine. Oh, I missed this minus sign. This is minus, and this is minus, so that's going to change that to a plus. And then you still need a plus c. There's the answer. So it's like a formula in that it's telling you how to piece your answer together. But of course, you have to practice picking out u's and v's, taking the derivative of u, integrating the v prime, and then piecing it all together. So before I show you the tabular method, let's skip to the back page here and do one more. Let's do this question 1 just for one more example real quick. Okay, so you're going to pick something for u, and then we're going to take its derivative, u prime. Whatever we don't pick for u, the rest is going to be v prime, and we're going to integrate that to find v. If I can find those 4 things, my answer is going to come from u times v minus integrating v u prime. This is the integration by parts formula. Okay, so it's kind of like u substitution, that if you pick the wrong thing, it's not that big a deal. You just might have to start over. But they did give us some tips here, because one way is going to work and one way is not going to work. X should be the thing that gets smaller as you take the derivative. So you think, or u should be x, so that the derivative is 1 dx. You really should keep up with that dx. It's going to help us. Whatever's not u is going to be v prime, so that would be cosine x dx. And we're going to need to integrate this. What can I take the derivative of to get cosine x?
Sine of x.
Okay, again, just be careful there. You know, sometimes you switch to sine, sometimes you don't. Depends on if you're talking about derivatives or integration, or sine to cosine or cosine to sine. Okay, and now it's a matter of plugging this in and doing one more step of calculus. I've got u times v is the first part of my answer. X sine x is this. Okay, minus integrating v u prime. This is why you should not just say 1. You should say 1 dx. You know, it doesn't make sense to integrate without the dx or du or whatever you're talking about. So x sine x minus, what can I take the derivative of to get sine?
Negative cosine.
Very good. Negative cosine, and you should never forget the plus c. Now, if you want to take a minute and do the derivative, remember this is the antiderivative. Now, to check this and do the derivative, you're going to have to do product rule here, but when you combine it with this one, all of it's going to simplify to just be x cosine x. So it's a process, and the more you practice the process, the easier it'll get. Now, I will warn you that some of these questions in here, sometimes you have to do integration by parts more than once. Like you're going to do this, and then when you get down to this integral is going to be integration by parts again. And in theory, you can do it as many times as they feel like making you do it. Your AP exam's probably not going to make you do it more than once. Or twice, I mean. So there's a second method. Again, this method doesn't always work, but it's especially nice. Go back to the first page on the tables. It's especially nice if it's a problem where you would have to do integration by parts multiple times. So this is also worth practicing at times. So we are going to pick out our u. Remember, they're calling f of x what I call u, what most people call u. What do you think in this question 2 should be f of x? Okay, and how do you know that? Right, it gets simpler the more times you take its derivative. In fact, we're going to take its derivative until we get to 0. This is how you do the table method. Pick out what u should be. It should be the same u as if you weren't doing the tabular method. and take the derivative all the way down. Pick the rest of your stuff to be your v prime or g prime if you want to go by functions. So the rest of this would be sine x dx. Okay, what we need to do is we need to integrate this as many times as we had to take the derivative of this one. So, what is the integral of sine x? Negative cosine. Again, be careful with the positive and negative. Slow down a little bit. What is the integral of negative cosine x? Okay, what's the integral of negative sine x? Okay, the integral of cosine is, and the integral of sine is, okay, you got to do it the same number of times as you had to take the derivative. Okay, next up we are going to connect these. So the first one here connects to the second one there, second connects to the third, third connects to the fourth, fourth connects to the fifth, and fifth connects to the sixth. 0 doesn't go to anything. And then you have to follow what they're calling the sign convention, which is where you alternate plus or minus. Plus, minus, plus, minus, plus. Now, you're going to think, if I was you, I would think this is kind of a long setup. However, this table method, what?
Could you also do minus, plus, minus, plus, minus?
No, it's got to be plus first. Now, when we piece these together, here comes our answer. These two make up the first term. Positive negative cosine x times x to the fourth. So negative x to the fourth cosine x. That's our first term. Our second term is going to be this stuff. Negative times a negative sine x times a 4x to the third. In other words, positive 4x to the third sine x. Okay, what do you think the next term is going to be?
12x squared cosine x.
Correct. Plus 12x squared cosine x. Okay, somebody else make a guess what you think the next term would be?
Negative 24x.
Very good. Negative 24x sine x. And then finally, the last one, minus 24 cosine x. And of course, plus c. So I don't know if you did that one by integration by parts. I don't know how many times you'd have to do the integration by parts. Probably 2 or 3 times. Each time you had to do that integral, I think you'd have to do integration by parts a second time. So this is much faster than doing that multiple times. So our u is still the same u, derivative down to 0. Everything else is our v prime. Integrate it till you have the same number of rows. Then do this sign convention. You might want to underline this because it's easy to miss. These two connect, positive. Second term come from these two multiplied together, negative. Then these two multiplied together, positive. Then these two multiplied together, negative. Then these two multiplied together, positive. However many times you need to do that. 0 doesn't go to anything because 0 times anything would be 0 anyway. So that's the tabular method. Okay, so I would like you to practice a couple of these. Again, I'm not interested in you doing a ton of them today, but maybe if you guys would try, we already did number 1 together. Maybe if you would try number 2 and number 8. And I'm going to give you a suggestion. I would do number 2 like this. Sort of like the u substitution, and try number 8 using the tables. 2 and 8. So do those 2 for me first. Make sure you feel okay about those. And then you can spend the rest of the time on handout 7, which is your homework. Handout 7 does have the correct answers on the bottom of the back page, so you can make sure you're doing those correctly too. So again, I'm only asking you to practice 2 of these integration by parts today. then. Let me get these homeworks checked off so I get these back to you in case you need to use them for your homework.
Mr. Townsend, in number 2, do I have to do it where I account for chain rule? Because of the 3x plus 1 inside of the cosine?
Yes. And make sure you realize you're integrating there. You're going from v prime to v. So yeah, you got to think about chain rule. So you should squeeze a 1/3 into your stuff.
Got it.
Hi, how are you?
Fine.
This blocks you almost completely.
Yep. That's why I don't like it.
Do you happen to have a crate in there that I can get to put some dry erase boards in for Blackie?
A crate?
Yeah.
I don't know that there is a crate, but you can go look.
Well, I saw some in there, but they had stuff in them, and I just didn't know what your system was, so I didn't want to mess nothing up.
As long as there's not calculators in there, it's fine.
Okay.
You can just dump it out.
Okay.
Mr. Townsend,
Yep.
do you, when you're integrating that,
Mm-hmm.
and it goes to sine, right, of 3x plus 1, and then your 3x plus 1, wouldn't that turn into 3x squared over 2 that you're multiplying?
Mm-mm. You're doing these separately because it's not sine times this stuff, it's sine of this stuff. So check by taking the derivative. The derivative of sine something would be
Sine of, or cosine.
okay, so that gives you cosine something. But because of your derivative, you see how you'd multiply by 3 because of chain rule? Was there a 3 there? So you want that 3 to go away. So you need to multiply by 1/3.
Okay.
Put a 1/3 up front.
Why do you not just do it the regular way? Right, because if you were integrating that, just 3x, it would turn into 3x squared over 2.
That's true.
You're saying it doesn't turn into that because this is inside of a sine.
Correct, yeah. It's sine of that stuff.
Okay. Thank you.
You could do 1/3 What did you like? month, right? You gotta make.
You know what you got.
Are you serious?
I have a 2/3. So when you from here to here, you're missing a 1/3. If you take if you take the derivative of this, you're going to multiply by 3 because the chain angle wasn't there. So there needs to be a 1/3 there.
I got 2x sine.
And so then you did this twice here because when you're integrating this, you get a 1/3, and there should be a 1/3 from up there. So there should be a 1/9 there, and then it's okay.
Thank you.
I don't know if that's a good way. So it's 2/3. Put it up to the top.
Going outside, where's the end of the morning?
Yeah.
Oh, is it?
Yeah, that looks pretty good. No, I didn't memorize this stuff.
By 3 fifths.
With the negative period with the negative 2/3, you can bring it to the top. It's supposed to be like that stage.
No, the negative just stays there all the time.
But there were 2 negatives. It's like
What was the second one?
because whenever you now.
People really don't like it when they get bullied.
Oh, no, I think I did that wrong.
This is where it's
Okay, that's because whenever you differentiate, yeah, when you differentiate, or when you,
Yes, that's good.
no, that's the line. When you take the derivative of.
I'm the one with the good handwriting.
You think you're the only person with good handwriting in here?
It has to be negative.
No, but the one with the best.
You just knew.
I don't know. Calvin's got some pretty good
It has
handwriting.
to be negative cosine.
Calvin is over there with the red water bottle.
Oh.
He's got some pretty good handwriting.
You know, sometimes I can read things I write.
What?
Sometimes when I write things down, I can like read them after.
Hey, you're supposed to be able to read what you write.
He said sometimes you can read it after.
You're supposed to be able
So
to.
then would that be carried out?
That's never happened.
Yeah, should be possible. Right. Well, this is negative already. Oh, you're where you used to. That would be positive. So
Right. So then it wouldn't change.
Yeah.
Oh. I think it's starting to make more sense.
Do you have to do anything with the years plus minus?
I just leave it as it is.
You're really pretty mad on that, but then you differentiate that.
I might have to add a 1/3 actually.
When did you use this in the real world?
Yeah. Because imagine
How much you?
we're taking the derivative of
Yeah,
this.
it's
Yes.
H.
Yeah.
How would you use this in your rate?
This math.
So we might have to add a 1/3 here, so we'll take the derivative. We end up getting.
You take the derivative, you take this now by 1, acceleration, limits, that would be divided by.
I don't know. Okay, sure.
That's how you use it.
Especially since this natural life one.
Yeah, regulars. Yeah.
Who put times
Makes my brain hurt a little bit.
Yeah.
These are just good.
Remember, I like to be a bit easier.
Okay, I'm sharing my answer to number 2.
One's in there, or we just just using these for students.
For students, I don't buy them for students.
You didn't buy any dry erase for students to go with the whiteboards?
To go with the whiteboards.
Yeah, the individual whiteboards for students. No? Okay. I'm just like, because she's new and she don't have anything.
Was there whiteboards in her room when she got there?
No, because she has a room that wasn't a math room.
Braden's correct, I get that.
I'm pretty bad.
It hadn't been a math room since Meredith had it like 3 years ago, 4 years ago.
I don't know. I don't buy whiteboards and markers for every teacher because not every teacher does that.
Right,
So-
okay, okay. I don't know. I found whiteboard and I found some eraser packs, but I only took part of them because I could share them. But I'll have to find some markers for her.
Okay, I mean, she can use some of those, but you know that I don't get extra money for the closet, so
Yeah, exactly.
if she gets double, then
Okay, just, like,
I
she
mean-
can borrow them until she gets hers with her instructional money.
yeah, she has her instructional money now though, so
Okay.
she should be using it.
Thank you.
Okay, you guys are gonna have some mistake or two on this number 2. I'm almost certain every paper where someone has shown me has had the same mistake here. If you don't, okay, so I'm sharing the answer with you so that you know if you need to go look for it, but especially the part I think you might be missing is this. That's not a 2, it should be a 2/3, and this isn't a 2, it's a 2/9. When you're integrating those steps in there, there's one step of chain rule that's being undone. You either A, have to do U substitution so you don't miss it, or B, you need to check your integration by taking the derivative. When there's a chain rule piece in there, you need to adjust. So I prefer not to do U substitution for just that, but if you're missing that, then you need to. So if you don't have that, you might need to look back at it again and see if you can come up with that as an answer. Yeah.
I don't know if this narrow up here or if it's like I'm trying to simplify, but I don't see how that gets to 1/3 actually to 2.
Integrated as usual, which means the 3, but 1/3 come out to 1/3. Simple as that. So yeah,
This is the one on the top.
Well, this goes to 0. Natural log of 1 is 0.
Oh, that makes sense.
So that's where part of it's going away. But then you still have something here. 2/3. It should be a 1/3.
Wouldn't it all go to 0? And I feel like there's something wrong up top because if I did those added to each other, that'd be the same thing as that minus that, and that'd just be 2 over 2, which would be 1, and then it would just turn to 0. Right?
It sounds familiar.
No.
Oh, right here. You got 2/3 of something
It's the same thing,
minus 1/3 of the same thing. Is that a natural log of 2 also?
Yes.
So if you have 2/3 of something minus 1/3 of something, you end up with 1/3 of the something.
Okay.
So I think you just need to combine like terms there at the end.
Okay. Thank you.
Well, multiple. Yeah, 1/3. Yeah, 1/3 times 3.
Okay, I'm also sharing my answer to number 8. Again, if you do number 8 the formula way, more power to you. But this one you would have to do multiple times. Oh, you can't see that. So if you did not get that for number 8, you need to try to see what looks different and try to learn from your mistake. make sure you correct that number 2 and number 8 before you move on to the homework. And we still got about 22 minutes, so even if you haven't started on the homework yet, you should still get a chunk of it done. And the homework is not over this, it's over the partial fractions.
I gotta turn this as well. For the answer says one thing.
Oh, yeah, I saw
You know what that is?
One more time.
I'm pretty sure it's 2.
That's what I'm thinking. I can feel like I'm
Is
doing
number 7 the home?
Yeah. 1%. Yeah, I see that. I just give me less.
Okay,
I don't understand why it works.
Yeah, exactly. Why
Why does that work?
Actually, tells me it's all.
Yes.
Yes, step by step, exactly that
I
song.
don't know.
Is that an extension?
No, you just look it up. It's a web browser.
I like the accent.
Easy.
I'm not use that.
That's not the, that is free, that's the best part.
Sorry. That's
Or you're not gonna do the crossover thing?
I mean,
or you're
right.
just trying to oversimplify it real quick?
Just simplify.
So 6dx.
Oh, you do this separate. Oh, okay, you don't do them all together.
Barbie Brains.
That's what you were saying.
Just makes it easier to see that.
Hopefully not.
No, if you already know that it's
I
EDX.
mean, literally killed me.
Literally.
Just literally
Okay. Let's see that. Let's quit.
Plus minus, plus Who's that asked the question?
It's probably cool.
Okay, if you were not able to get those answers for 2 or 8, please call me over and let me look at your work so I can point out to you what you need to do different.
Yeah.
Did everybody get this number 8 with the table method? This is a yes. It's a yes unless someone says no. That's fine, I just don't want to waste time on it. What about the number 2?
Me, Braden, and Blake got it right. Oh, that's
Everybody got this number 2 right, doing the integration by parts. Okay. So on Wednesday, part of what I'll have you do is practice this some more. Again, I'm just kind of introducing it to you. At this point, you should know there's a formula. You pick out a U and a V. There's the table method. Sometimes you have to do it more than once, is where the table method would shine. But short of that, you don't need to feel like an expert yet. You're just kind of getting introduced to it. We'll actually practice it some next class. Now, if you want to work ahead and do more, you're welcome to. But the one thing I'm asking that you finish up for homework so that I can take it up next time is this number 7. The 6 partial fractions. And again, the answers to those are on the bottom of the back page. So make sure that you stick with them long enough to get to that spot.
Oh, you mean start? Well, what I did was, because this is all, you can combine it to be so I'm combining this one, and then it would be minus, and then you can just put this up to this, it will give you the square root, and now if you don't have denominator, it would be the x plus 2 denominator. Should you put this as the square root? Yes. It would not give you the square root of those, or should just the top? Because it's only applying to these two, because this doesn't. You're doing that when you do that. You can't combine on it, they don't. Well, you can't combine this into any of, like, you can't do this because this would apply to all of it. You can't combine them until they're just natural log. So you would have to combine this one first, and you put that one first, until you can do that. Why can't I just? Because right now this 1/2 is plus 2.
I went back and did number 9.
Okay.
It's the same thing. Well, that's because they're both, yeah, that's because they're both, yeah, it's the same as this. These are both 1/3, but this negative one doesn't have a 1/2 of it, so you can't combine this into this.
Last class, you're gonna number 1 again. I was supposed to go as fast. You're gonna test the partial fraction. Go on step 6.
Are we getting our number 3s back?
I already passed them back, didn't I? Did I not? Oh, okay. I meant to. Y'all are all done with homework?
Yes. Once we get the second semester, that's when we start getting.
Sorry, I thought I had given back your number 3 homework the other day. I was just writing down the last time and I forgot.
Email to make sure
Yeah, I just put it in. So.
Okay, cool.
Also, we do have advisory movement starting up on Wednesday this week. If you feel like you're falling behind on any of these 2 new topics, partial fractions or integration by parts, although you really should feel like you're behind on integration by parts because we haven't done much. Feel free to come sign up on Wednesday and come see me. Don't wait until the day before the test.
Anybody can learn what it's gonna be, just.
Probably about 2 weeks from now. Something like that. We need to get good at the integration by parts, and then we need to do proper intervals, and then we'll probably start. So maybe a little bit less. Okay, does anybody need some help? Can come around and help you? Integration by parts or the homework? I'm not going to take questions on the homework next time. You've got the answers to check too. It's the second time, third time you've seen it, and you've got class time to ask questions right now. So if you need help, you need to plan on asking that now. Yep. No, it's not true.
Yeah.
Can somebody explain the daily meme up there? Y'all get the joke? Why is the bottom one wrong?
5 is not a lone escape. It's not how infinity works.
Not a what?
Lone escape. 5 is 8.
Oh, okay.
The infinity sign.
I did your math wrong.
What's the...
I don't get what it is with Einstein though.
Because what's the answer to the second question? Okay, what answer did they write down?
5 is 5.
Okay, what was the answer to question 1?
Infinity.
Which is also known as
A lone escape.
infinity. So the person thought this one, the person didn't realize the first answer was infinity, they thought it was sideways 8. So then they thought the answer to the second one is sideways 5. So Einstein's mad and they're having to hold him back because that's ridiculous.
I thought he was the one who was doing that.
No, they're holding him back.
You're aware that today is August 26th?
What is special about August 26th?
There's no H on the board. It's still 26th.
It's 26th. 26th.
That was in your resume.
Well, you know what?
Your math teacher, not an English teacher?
Yeah, that too. If I didn't have like 400 small chores a day where I get distracted, then it would be...
You can't judge. You can still laugh about it though.
I feel pretty judgy. A floor function? Oh, the step function? Greatest integer? It came up in my AB class. We did an old AP question where they used to have to know that, so, and they didn't know what that graph looks like. So. No, we didn't. I'm using a different worksheet than last year. They don't have to know it for the AP exam, but we just went ahead and talked about it anyway.
Where does it change?
Because
Okay.
it would be natural log of x. But since this x is negative, it would be natural log of
That makes sense. So it's plus up here, but then when you integrate, it's negative. Here, it's chain rule,
yeah.
right? The chain.
Okay, we've got just a few minutes here, so first off, make sure that you know what you need to do for homework. For homework, you need to finish up number 7. So finish practicing those. Make sure you come up with the answers on the bottom of the back page. And I shared another puzzle with you on the board if you're interested.
This is not a puzzle, this is just math.
What math is puzzles?
So are we taking into account there's different right and left socks? Or
Yes.
I don't know.
my socks are just the socks?
No, they're identical, they're identical. No.
Okay. So
So
there's
it's well now, it's well now, it's all in white.
Well, you because the first sock you pick can be any sock, and then the second one you pick has to be 1 so it would be 1 over 12 minus 1. So it would be 1
It'd be 11, it'd be 6 out of 12. No, it's, no. Well, it's 12 out of 24, right?
No, 1. Because it doesn't say you need to get one specific color. The first sock you can grab is any
I
of
know,
the
that's what I'm saying,
socks.
12 out of, oh.
So yeah, it would be 12. You can take any of the socks. So it would just be 1, and then the second one would have to be 1 over 11.
So it's 1 over 11.
So yeah, basically.
You're right.
It would be 1 over 11.
What? No, I think you're right, that's the first one.
It would be 1 over 11.
But there's like 11 other songs. There's 10 other songs.
Yeah, it would be 1 over 11. Oh wait, yeah, you're right, because there are.
I thought it would be like that.
Have a good day.